Hello and welcome to section 6.2. We're going to be talking about factoring polynomials. In this case, we're just going to concentrate on simple trinomials, and that means trinomials of this form, x squared plus bx plus c. So here's the rule. We're given a polynomial of this form, x squared plus bx plus c. We attempt to find two factors of the constant term c whose sum is equal to b. Now this should make some sense based on the way that we handle multiplication. And I'll show you a really simple example for this first one. First problem, let's see if we can find two binomials whose sum, two binomials, right? So we're going to get two binomials. When we say binomial, of course, what we mean is that we have two binomial factors. And if we reverse the FOIL method, of course, that means that the very first term of each of these binomials must be x. The next term must be the factors of 12 whose sum is 8. So we think, okay, factors of 12 whose sum is 8. Let's see, can we think of two factors of 12 whose sum is 8? And the answer to that is, well, let's see. I know that 12 can be factored into things like 4 times 3, but that's not going to help me. I could also think of a factor pair like, how about 6 times 2? Well, 6 times 2 seems to work because 6 times 2 is 12. And we know that 6 plus 2 would be 8, so that must be it. So what we do is this. Both of these terms will be plus. 12 is factored into 6 times 2. So this should be our factorization. How do we know? Well, we know we can always check by just going back and doing the multiplication. And of course, if you do that right here, let's see what happens. By the FOIL method, we know that x times x will be x squared. X times 2 will be plus 2x. X times 6, the two inner terms will be plus 6x. And of course, the last term, 6 times 2, will be plus 12. So in this case, x squared plus 8x plus 12, our facts seem to fit the bill. So this is our answer right here. Okay. So how do we always do this? Well, in this particular case, it's actually a lot easier than it looks here. I know I kind of written this all out, but there are a couple of things we have to remember. First of all, any factors that we get are always going to be of the form x plus or minus a number, right? So we want to think, well, what numbers will go here? So in this case, we can think in number 2. Factor x squared minus 11x minus 12. We want to find two factors of negative 12 whose sum is negative 11. Well, negative 12 could factor into many things, but in this case, we know that another factor pair we didn't name before would be negative 12 times positive 1. Well, we know that negative 12 times positive 1 is equal to negative 12 when we multiply. What happens when we add them? Well, negative 12 plus 1 is indeed negative 11, and that's our middle term. So, two factors of negative 12 whose sum is equal to negative 11 would be negative 12 and positive 1. So the way we're going to fill in our factorization right here is that we're going to say that our two binomials, x would be our first term, and positive 1 and negative 12 must be our second term. And it doesn't matter which order you put these in. It could be x minus 12 times x plus 1. But that will be the factorization. Of course, you should always go through and check. And the nice thing here is that you know that the first and the last terms will always come out because, well, x times x is x squared. 1 times negative 12 is negative 12. But if we work with the two middle terms, the two middle terms are O and our I from FOIL. If we check those two middle terms, let's see what happens here. Looks like we're going to get positive 1 times x, so plus 1x, and negative 12 times x, so minus 12x. And yeah, sure enough, that adds up to negative 11x, which is exactly what we wanted. So we want to make sure that our middle terms are the ones that add up to that middle term. Okay, very good. Let's try one more here. Let's try this one. Well, it seems a little bit more complicated, but actually not so bad. In this case, we're going to have two factors, but because we've got x and y, right, we know that the first terms must contain x, and the last terms must contain y. And the reason why, why, is because, well, y times y gives us y squared, and x times x gives us x squared. So it's be something involving x and y. Now the question is going to be what? Well, in fact, we could think of this as being very much like writing x squared minus 8x plus 15 without the extra y term at the end. How would we factor this, right? This is a similar problem. So if we have a similar problem, sometimes we can work out how to figure our factorization for the more complicated problem. And we know that, well, 15 will factor into, let's see, positive 15 will factor into negative 3 and negative 5 to give us a positive 15 when we multiply, and negative 8 when we add. Right, so we want to add up, we want two terms whose product is positive 15 and whose sum is negative 8. Well, we do that right here, we get negative 8. And so sure enough, we're going to put in, if this factors as x minus 3 times x minus 5, then our more complicated problem will factor in a very similar fashion, except it'll be x minus 3y and x minus 5y. That's our factorization. More in the next video.